Hello and welcome everyone. This is Mohammad Inzamam from Saimedha Coaching Center, Koti, Hyderabad. In this video, we are going to be talking about the added syllabus of Genco EEE branch Thermodynamics concept. Make sure guys, this is a subject which is going to be the deciding factor for all the Genco aspirants of EEE branch. ఖచ్చితంగా ఈ సబ్జెక్ట్ నుంచి వచ్చిన మార్క్స్ వల్ల మనకు జాబ్ అనేది డిసైడ్ అవుతుంది. ఎందుకంటే all the other students, those who are not preparing for this subject, because this is a new subject for EEE students, they are not going to score much well in this subject. But whereas if you people are preparing for this syllabus also, definitely you are going to be having an advantage in the Genco AE examination. Already video 1 has been posted in the channel. This is the video 2. In this series, we are going to be updating regularly regarding this thermodynamics chapter and the added syllabus also. Make sure guys you subscribe the channel and press the bell icon to be notified for the further more updates. Daily updates గురించి మీకు వీడియో అనేది నోటిఫికేషన్ అనేది రావాలంటే ఖచ్చితంగా ఈ వీడియోని వాచ్ చేయండి, సబ్స్క్రైబ్ చేయండి, షేర్ చేయండి విత్ యువర్ ఫ్రెండ్స్ అండ్ నచ్చితే డెఫినెట్లీ లైక్ కూడా చేయండి. జెన్కో కోచింగ్ అనేది సాయిమేధ యాప్లో ఆల్రెడీ స్టార్ట్ అయిపోయింది. ఇన్ ద నేమ్ ఆఫ్ స్పేస్ గేట్ యాప్. స్పేస్ గేట్ యాప్ ఉంది మనకు. ఆ యాప్లో ఆన్లైన్ కోచింగ్ స్టార్ట్ అయిపోయింది. సాయిమేధ కోటి హైదరాబాద్లో ఆఫ్లైన్ కోచింగ్ ఆల్రెడీ స్టార్ట్ అయిపోయింది. ఓకే, మార్నింగ్ 6 నుంచి ఈవినింగ్ 8:30 వరకు మనకు ఫ్లెక్సిబుల్ బ్యాచెస్ టైమింగ్స్ ఆర్ దేర్. క్లాస్ రివిజన్ ఎగ్జామ్, క్లాస్ రివిజన్ ఎగ్జామ్, డైలీ మీకు క్లాసెస్ అనేది ఆఫ్లైన్ క్లాసెస్ జరుగుతూనే ఉన్నాయి. ఎవరైతే ఆఫ్లైన్కి జాయిన్ అవుతారో మై డియర్ స్టూడెంట్స్, వాళ్ళకు ఒక మంచి అవకాశం ఏంటంటే జెన్కో తర్వాత మీకు జెన్కో ట్రాన్స్కో డిఫరెంట్ కాంపిటేటివ్ ఎగ్జామినేషన్ ఏం పడినా సరే మళ్ళీ ఇంకోసారి మీకు ఆఫ్లైన్ క్లాసెస్కి అలౌ చేయడం జరుగుతుంది. ఓకే, ఫర్ అరౌండ్ రిజిస్ట్రేషన్ ఫీ ఉంటుంది. ఆ రిజిస్ట్రేషన్ ఫీ పే చేసుకుంటే సరిపోతుంది. ఓకే, ఆన్లైన్ విషయానికి వస్తే దోస్ హు ఆర్ గోయింగ్ టు బి జాయినింగ్ ఫర్ ఆన్లైన్ నౌ గైస్, వాళ్ళకు ఒక మంచి ఆఫర్ ఏంటంటే ఆఫ్లైన్లో ఏదైతే క్లాసెస్ మనం చెప్పుకుంటున్నామో ఆ ఆఫ్లైన్ రికార్డెడ్ వీడియోస్ కూడా మీకు ఇంట్లో మీరు కూర్చొని కూడా మళ్ళీ ఇంకోసారి వాచ్ చేసుకోవచ్చు. సో మై డియర్ స్టూడెంట్స్, వాట్ ఆర్ యూ వెయిటింగ్ ఫర్? ఎన్ని ఆఫర్స్ ఉన్న తర్వాత కూడా ఇంకా జాయిన్ కావట్లేదంటే యూ ఆర్ నాట్ ప్లానింగ్ ఫర్ జెన్కో ఎగ్జామినేషన్. డెఫినెట్లీ ప్లాన్ చేస్తున్నారంటే మనకు ముందు వరుసలో మనం ఉండాలంటే మన ప్రిపరేషన్ అనేది మన ఎగ్జామ్ కంటే ముందే కంప్లీట్ కావాలి. ప్రీ ఈసెట్ ఎగ్జామ్, ప్రీ ఎగ్జామినేషన్స్, ప్రీ జెన్కో ఎగ్జామినేషన్, గ్రాండ్ టెస్ట్ ఎగ్జామ్, మాక్ టెస్ట్ ఎగ్జామ్. Before that only, if you want to write guys, if you want to complete your entire syllabus before the Genco examination only, as soon as possible join in the Saimedha Koti, Hyderabad. Okay, so let's start the video now. This is the actual video 2. Video 1 already link description lo untadi. First our video watch cheskondi and then you can continue with this also, or else you can watch this video also. Anyhow, this concept is going to be a different concept from the previous video. Let's start the question number 1. The question number 1 given is measurement of temperature is based on. Okay, let me give you about all the brief introduction about the 0th law, 1st law and the 2nd law. Okay, now this first law of thermodynamics is going to be having, okay, just a second, we'll take this background in here, okay, with which we can understand it much well. 0th law of thermodynamics. So what is this 0th law of thermodynamics? 0th law of thermodynamics talks about, okay, 0th law of thermodynamics talks about thermometry. Thermometry, that is, therm means what? It is heat. Heat here refers to temperature. Okay, metry, what is the meaning of metry? Measurement. Temperature measurement or measurement of temperature. Measurement of temperature is coming from where? 0th law of thermodynamics. How is it given? 0th law of thermodynamics statement, let's try and understand with this diagram. Suppose we are having a beaker in which water is there, some water is there, and we are inserting a thermometer in. Okay, so this thermometer is having a bulb inside which we are having mercury. Okay, this mercury is going to be water expanding and showing us a particular temperature. Okay, so we know that this temperature, whatever this temperature is shown by mercury from the 0 value, that will be read in directly degrees Celsius or Kelvin or Fahrenheit depending upon the temperature scale. So actually there are 3 bodies in interaction here. The first body is water. Water is interacting with the bulb of mercury, bulb of thermometer, and inside which we are having mercury. So, this zeroth law works on a concept of thermal equilibrium. What is the meaning of thermal equilibrium? All temperatures will be same. Heat will transfer whenever we have the temperature difference. Heat transfer takes place. Remember this point? When the heat transfer will takes place? Heat transfer takes place when bodies have temperature difference. Bodies have temperature difference. When both the bodies are attaining the same temperature, until then heat will transfer. Once they are attaining the same temperature, then what happens? Heat will not transfer. So, heat first of all transfers from water to bulb, from bulb to mercury, unless temperature of the water and temperature of the bulb and temperature of mercury are going to become equal with each other. So, here comes, let us say this is a body A, this is body B, this is body C. So, statement how can we say here is, when two bodies, let us say A and B, are in thermal equilibrium with the third body, let us say C, then these three bodies are said to be in equilibrium with each other. Two bodies A and B, thermal equilibrium with the C, then they are in equilibrium with each other. This was given by zeroth law of thermodynamics. Sir, mercury is measuring the temperature, so that could be the temperature of mercury. How can we say that that is the temperature of water? Because of thermal equilibrium, we can say that when three bodies are in thermal equilibrium with each other, then all of the three bodies are going to be having the same temperature. That is, temperature of water, temperature of the bulb and temperature of mercury are equal under thermal equilibrium. Zeroth law of thermodynamics is based on thermal equilibrium. Okay. Now, let us come back. First of all, let me write the definition also here. That is zeroth law of thermodynamics definition. What is the definition of zeroth law of thermodynamics? It states that when two bodies are in thermal equilibrium with the third body, then they are said to be in equilibrium with each other. This is the statement. They are said to be in equilibrium with each other. Okay. So, what are the important points now? You need to focus upon, first of all, zeroth law of thermodynamics statement. When two bodies are in thermal equilibrium with the third body, then they are in equilibrium with each other. Then we need to focus on zeroth law of thermodynamics is based on, it is based on what? Thermal equilibrium. What does it measures? Zeroth law of thermodynamics measures what? Temperatures. That means we need to focus on a word called as thermometry. Okay. Now, let us go back to the question. Measurement of temperatures. What is the measurement of temperatures called as? Thermometry. So, this thermometry is coming from which law of thermodynamics? Thermometry is coming from zeroth law of thermodynamics. So, what is the answer for the question number 1? Zeroth law of thermodynamics. Okay, go through it once. Chalo, pause the video and note it down so that we can go for the next question. Okay, let us continue with the next question now. The next question given is, which of the following is an extensive property? Sir, what is the meaning of extensive property? Okay. We need to know now about what is the extensive and intensive property. Extensive properties are the properties which are dependent on mass. These are also called as extrinsic properties. Okay. What does depends on mass? Examples are, mass depends on mass, yes. Volume depends on mass, yes. Energy, all sorts of energies depends on mass. Energies are enthalpies and energy, that is heat energy, entropy, instability of the molecules, this is also energy, heat energy, work energy, kinetic energy, potential energy, okay. All comes under what? Extensive properties. For the now, you need to memorize mass, volume and energy are the examples for extensive property dependent on mass. Whereas, on the other hand, we have intensive properties. Intensive and intrinsic both are same. So what is the meaning of intrinsic and extrinsic properties? The properties which are independent on mass. The properties which are independent on mass. What are the examples of independent on mass? Example number 1. Example number 1 is density. Density is usually formula, when formula is given people get confused. Density is mass by volume, but it does not depend upon mass. Mass మీద depend గా density. Density అనేది molecular structure. How closely the molecules are packed in a definite manner for a given volume. Okay, for take an example, let's say we are having what, steel. Okay, I am having a steel rod. This is a steel rod of 1 kg. If I cut the steel rod of 1 kg to half kg, then what is the density of the steel? Density of steel value is 7850. Okay, kg per meter cube. Per meter cube, what is the mass it is going to occupy? Here density of steel is, it's not going to become half, right? Density will be remaining constant, 7850 only. What is the density of water? 1000. If you take a 1 liter of water, take 1 kg of water, cut it into what, half kg and half kg. Okay, if water is converting into half kg and half kg, does density of water changes? No. Mass is changing, but density doesn't change. So density does not depends on mass. Remember that. Don't get confused with by seeing the formula. Okay, formula is okay, but actual meaning of density is molecular structure here in a given volume, or per meter cube, how many kg. For 1 meter cube, it is always occupying 7850 only. Okay, so it doesn't depends upon mass. It is also called as, density is also called as specific mass. Okay, mass density. It is an example of which property? Intensive property. Example number 2 for intensive, temperature. Okay, temperature also doesn't depends upon mass. All specific extensive properties. Whenever you see this word specific, specific mass, specific enthalpy, specific entropy, specific energy, specific means intensive, that is per unit mass. All specific extensive properties are intensive. All specific extensive properties are intensive. That means examples are what now for intensive? Specific mass. Mass is an extensive, specific mass intensive. Okay, energy is extensive, specific energy is intensive. Enthalpy is extensive, specific enthalpy is intensive. All specific properties are intensive. One more is there, that is pressure. Pressure is also which property? Intensive property. Pressure does not depend upon mass. Pressure depends on heights. If heights changes, pressure changes. We go inside depth, inside the water. You go deep inside the water, pressure increases. Okay, you are going onto the mountains or hill stations, pressure decreases. So with heights, pressure changes, but pressure doesn't depend upon mass. So pressure is also a property, intensive property. Now let's come back to the question and see what is the correct answer for it. Okay, question given is, which of the following is an extensive property? Go through it. Okay, temperature is a which property? Intensive property. Pressure is a which property? Intensive property. Density is a which property? Intensive property. So we have left out with what? Volume. Volume is which property? Extensive. For proving it, let me say this is a jar. Okay, having some lid. It is having some volume. If I remove the jar and only I am having a lid, okay, only I am having the cap here, does volume changes or not? Yes. Mass changes. Here mass changes. I have removed this bottle, okay, only lid is remaining, then volume changes or not? Yes, volume changes. Mass changes, volume changes. So volume is which property? Extensive property. That's why we need to keep the correct answer as what? Volume. Go through it once. Okay, you can pause the video at any time and note down all these important points here. Okay, in detail we are going for the explanation. A question is given, throughout that question what are the topics are there we are covering. Okay, chalo, pause the video and note it down so that we can go for the next question. Okay, go for it. What is the standard fixed point for the thermometry? Remember this one, thermometry. We are coming back to the thermometry again here. Here I will write thermometry starts with 0 degrees Celsius. That is called as triple point of water. What is it called as? Triple point of water. Where triple point is a condition where solid, liquid, vapor, will exist in equilibrium, will exist in equilibrium, that is 0 degrees Celsius. Okay, remember that point, that is 273 Kelvin also we can say, 273 Kelvin. 1 by 273.16th part of triple point of water is called as Kelvin. So what is that thermometry, what is the base, what is the standard fixed point from where the thermometry starts, that is 0 degrees Celsius, 273 Kelvin, that is called as triple point of water. Triple point is a condition where ice, water and water vapor can coexist under equilibrium at a pressure of 611 Pascal, 0.006112 bar. Okay. This is called as triple point pressure, and here we have is triple point temperature. What we require is this temperature. What is the condition at which it is fixed? Triple point. What is the question asked here? What is the standard fixed point for the thermometry? Thermometry standard fixed point. What is the correct answer going to become now? Triple point of water. That is temperature is around 0 degree Celsius. Let us go for the next question. Pause the video, note it down. When two bodies are in thermal equilibrium with the third body, statement already we discussed, 0th law of thermodynamics statement. What is the statement of 0th law? Go through it. When two bodies are in thermal equilibrium with the third body, then they are said to be in equilibrium with each other. When two bodies, water and bulb, are in thermal equilibrium with the mercury, then temperature of mercury, temperature of bulb and temperature of water are equal. That's the question asked here. Okay, go through it. Question number 4, when two bodies are in thermal equilibrium with the third body, then they are said to be in equilibrium with each other. This statement is called as 0th law of thermodynamics. Go through it once, pause the video and note it down. So let's move on to the next question now. The next question given over the board is, the first law of thermodynamics is the law of. So first of all, let's discuss about this law, then we are going to solve the question. Okay. So what is this first law of thermodynamics? The first law of thermodynamics states that heat and work are mutually convertible. Heat and work are mutually convertible. That means heat transfer is converted to work transfer is converted to heat transfer. Cyclic integral of heat transfer is equals to cyclic integral of work transfer. Cyclic integral of heat transfer minus work transfer is equals to 0. In a closed system, if we see, we supply which energy? Heat energy. This energy will be absorbed by the gas molecules and increasing the temperature. That is called as change in internal energy. This is the energy with which the temperature of the molecules increases. And a part of that heat energy will be utilized for doing the work. That is, this piston will be moved in the backward direction, creating some displacement, force times displacement, that is which energy? Work energy. So what we can say here, that heat energy is converted into work energy. Suppose heat energy supplied is 100, energy utilized for increasing the temperature is around some 20, then work done will become how much? 80. So if I write the equation, 100 is equals to 20 plus 80, what is the meaning here? 100 is the heat transferred. 100 is the heat transfer. This 20 is change in internal energy to increase the temperature. Change in internal energy. Change in internal energy. Plus this 80 is work transfer. Work transfer. So d dash q is equals to, you can write the formula now, heat transfer, that is d dash q, change in internal energy du, denoted with du, plus d dash w. So what is the first law of thermodynamics equation going to become? Heat transfer is equals to change in the internal energy plus work transfer. Remember this. In this, you are having two important points, that heat is, suppose denoted with q, so heat is supplied is given, then it is going to be taken as positive. Heat is lost is given, taken as negative. Similarly, work done on the system is given, work done on the system, that means we are supplying the work, that is negative. Work done by the system is given, by the system, that is expansion work. Expansion work is what? A positive. Expansion, work of expansion is positive and work of compression is negative. Okay, the sign conventions are very important while solving the problems. In short, what is the first law of thermodynamics is talking about? First law of thermodynamics is talking about the conversion of heat energy into work energy. Energy is converting from one form to another form. So, first law of thermodynamics is depending upon what? Law of conservation of energy. Law of conservation of energy. First law of thermodynamics depends on dash. What is the answer? Law of conservation of energy. Go through it once. Go through it. First law of thermodynamics states that heat and work are mutually convertible. Heat can be converted to work can be converted to heat energy. What is the cyclic total entire formula? Heat transfer, work transfer are proportional to each other. Cyclic net heat transfer minus net work transfer is going to become 0. What is the process for differential equation? Heat transfer equal to internal energy change, that is temperature increases plus work transfer. If internal energy is remaining constant, that means there is no increase in temperature. Remember that. Okay, temperature ni increase cheyadaniki work cheyadaniki heat energy anedi utilize avutundi. Suppose temperature increase kavatledante heat transfer work transfer are going to become equal with each other. Okay, in detail when the question appears I will tell you one more time. For now, what we need to memorize? First law of thermodynamics talks about heat and work conversion of energies. Law of conservation of energy. Let's come back to the question. You can pause this video and notice all the important points and we'll go for the question number 5. First law of thermodynamics. Now answer the question. What is the question given here? First law of thermodynamics is the law of conservation of heat, momentum, energy, mass, conservation of energy, because first law talks about net heat transfer is proportional to net work transfer. Net heat transfer is equal to net work transfer. Heat transfer minus work transfer is equal to 0. Okay, for a cycle. For a cycle. Go through it. Law of conservation of energy. Let's move on to the next question. Question number 6. Cyclic integral of, that's what he is asking now. Cyclic integral of d dash q minus d dash w. What is the value? 0. Already we discussed in the first law of thermodynamics itself. What is the answer for this question gonna become? 0. Go through it. Cyclic integral of net heat transfer minus net work transfer is equal to, what is the answer? 0. That's the question appeared. Question number 7. If the work done on a closed system is 40 kilojoules, work done on a system, work done on the system is always which work? Positive or negative? It is a negative work. So that's why you need to take minus 40 here. Okay, minus 40 is kilojoules per kg. Heat is rejected. Rejected is the loss of energy. So what we can write now? Heat rejected, heat loss is minus 80 kilojoule per kg. Then internal energy is, what is the first law of thermodynamics equation? Heat transfer equal to change in internal energy plus work transfer. Heat transfer value is how much? Minus 80. Internal energy we need to find. Work transfer is minus 40. Okay, go through it. If you don't know the sign convention, on the system is negative, rejected is negative, what are you going to keep there? You will keep here 80, this is plus 40, 80 minus 40, you will be getting plus 40 as the answer. But now the correct answer is minus 80 plus 40 equal to du. Then minus 40 will be your answer. What is this minus indicates? Decreases. This minus indicates what? A decrease in the internal energy. Go through it once. So what is the correct answer going to become? Decrease. If you don't know the sign convention, you will keep the third one as the correct answer, but that's absolutely wrong. This is the correct answer. Okay, go through it once. Try to memorize the formula for first law of thermodynamics differential equation. d dash q equal to du plus d dash w. Okay, let's pause the video, note it down. Let's go for the next question. Specific heat. Okay, regarding the specific heat, some important equations are there that we need to memorize. What are they, sir? The first one is Cp minus Cv equal to R. Cp by Cv equal to gamma. That is where Cp is called as, this is from the first year diploma physics or first year inter physics, specific heat at a constant pressure. Specific heat at constant pressure. Cv is called as specific heat at constant volume. Specific heat at a constant volume, whereas gamma is called as adiabatic index, R is called as characteristic gas constant. Okay, so now we know two relations, Cp minus Cv equal to R, Cp by Cv equal to gamma. From these two relations we can write the formula of Cv and Cp in terms of R and gamma. Observe the equation number 1, Cp minus Cv equal to R. Shall I divide this entire equation divided by Cv, Cv, Cv? What is it going to become? Cp by Cv. Cp by Cv is gamma. Cv by Cv is 1. R divided by Cv. So this entire expression to the left hand side, this Cv to the right hand side is going to become Cv equal to R by gamma minus 1. So this is the formula for Cv. Second equation is what now? Sir, we know Cp by Cv is equals to gamma. So Cp is equals to gamma times of Cv. Cv formula already we derived. What is the answer? R by gamma minus 1. So the answer is R by gamma minus 1. Cp is always greater than Cv. Remember that. So Cp is larger value is having multiple gamma, R by gamma minus 1, Cv is having R by gamma minus 1, two standard formulas. Okay. Specific heat at constant pressure, specific heat at constant volume. Okay, what is the question asked now? I am expecting in the Genco examination or any other competitive examination for basic level, this will be your question asked. Cp minus Cv equals to R. Go through it once. And now let us see the question one more time. Asked the question is specific heat at constant volume, Cv equal to, we know the formula for Cv is R divided by gamma minus 1. Whereas for Cp formula, specific heat at constant pressure formula, gamma R by gamma minus 1. Okay. So this is Cv R by gamma minus 1. Where is the R by gamma minus 1? You have in the option number 1. So R by gamma minus 1 is going to become the correct answer. Okay. Go through it once. Pause the video and note it down. This one also. Let's move on to the next question. Question number 9. A system undergoes a process in which the heat transfer of the system is 30 kilojoules. Heat transfer is given as 30. Work done by the system, that is positive work again, that is 35 kilojoules. Okay, actually this is 35,000 he mentioning here. Okay, let me write it in the form of, there is 35,000 Newton meter. Newton meter means joule. This 10 cube means this is kilo. So this is 35 kilojoules only. Okay, work done is 35 kilojoules. Remember, Newton meter and joule both are same. Okay. Now change in internal energy is asking the question. Change in internal energy equals to what? What is the formula for, according to the first law of thermodynamics? Heat transfer equals to internal energy plus work transfer. Where heat transfer form value given is how much? 30. The internal energy we don't know. Work value is given as 35. 35 coming to the left hand side, du will be equal to what now? Minus 35 plus 30. That is plus 5 or minus 5? Minus 5. Minus indicates decreases. So what is the correct answer going to become now? Minus 5 kilojoules. Again, this is the formula that we need to memorize. Heat transfer equal to change in internal energy plus work transfer, according to the first law of thermodynamics. Try to memorize the formula, substitution and get an answer. Okay. Go for the next question. The work done in the expansion of the gas from volume V1 to V2 at constant pressure process is. Generalized formula for work done in a closed system or non-flow system, reversible work, non-flow reversible work. Okay. The formula is d dash W is equals to, remember these two formulas actually, work done for a closed system, reversible work, or non-flow reversible work. The formula is d dash W is equals to integral of P into dV, where P is a constant because in the question he mentioning that constant pressure process. So P we have taken common, integral of dV within a limit of volume V1 to V2. Integration of 1 dx, x, integration of 1 dV, V within a limit of V1 to V2. Upper limit minus lower limit. So what is the formula now? P into V2 minus V1. This is the formula for work done in which system? Closed system. At what process? Constant pressure process. constant pressure process. P into V2 minus V1. In short, general formula also we can write. Sir, work done is force into displacement. Here force is pressure into area. Area into displacement is change in volume. Pressure into change in volume. Total change in volume from V1 to V2. Change in volume formula V2 minus V1. So what is the formula for work going to become? P into V2 minus V1. So this is a general equation from force into displacement also we can derive. So what is the problem answer gonna become? Constant pressure process, answer is P into V2 minus V1. P into V2 minus V1. Okay, option number 2 is going to become your correct answer. Go through it once, pause the video and note it down. Let's go for the next question. Okay, so this is all about the till the question number 10 we have discussed. Okay, go through all the important points. Okay, I'll give you the slide number 1, starting from the slide number 1, so that wherever you want to pause, you can pause it. Okay, so we have started from here, slide number 1. Pause now if you want to note down the answer. For question number 1, the answer is what? 1. Measurement of temperature, 0th law of thermodynamics. Then we have discussed about a little bit of explanation about the 0th law of thermodynamics. That is, when two bodies are in thermal equilibrium with the body third, then they are in equilibrium with each other. Okay, you can pause it here also and note it down. 0th law of thermodynamics statement we have discussed. Triple point of water we have discussed. And this is the question number 2. Which of the following is extensive property? In detail about the extensive property we have discussed in this very slide. You can pause it here and note it down if you haven't noted down. Okay, let's go for the next question. Question number 3. What is the standard fixed point for the thermometry? Triple point of water. Then two bodies are in thermal equilibrium with the third body, then they are in equilibrium with each other. This was given by which law of thermodynamics? 0th law of thermodynamics. Then we discussed about first law of thermodynamics, conservation of energy. In detail we discussed about the first law of thermodynamics, formulas of first law of thermodynamics, when it is positive, when it is negative also we discussed here. Then we discussed about cyclic integral, answer is what? 0. 7th, we discussed a problem on a system is negative, heat rejected is also negative. Then we derived the formula for Cv and Cp, R by gamma minus 1, gamma R by gamma minus 1. Then we discussed about some relation Cp minus Cv R, Cp by Cv gamma, then derivation of the formula for Cv and Cp. You can pause it here and note it down. Question number 9th, we discussed again the problem on first law of thermodynamics, heat transfer, internal energy and work transfer, followed by the last question, that is work done, V1, V2. What is the answer? P into V2 minus V1. So this is all about the today's class. 10 questions at a time, 10 to 15 questions, most expected questions in the examination. So make sure you are watching all these videos, writing the notes, trying to memorize the formulas, and these bits are gunshot bits, so definitely go through it once. If you are able to crack these bits in Genco also, in different competitive examination also, definitely you are able to crack these bits very easily. Okay, so my dear students, those who have not subscribed so far, subscribe the channel. And offline coaching anedi Saimedha Koti Hyderabad lo start అయిపోయింది. ఆఫ్లైన్ కోచింగ్ కి ఎవరైతే జాయిన్ అవుతారో గుర్తుపెట్టుకొని మళ్ళీ ఇంకోసారి ట్రాన్స్కోలో జాబ్ పడిన తర్వాత కూడా మీకు ఆఫ్లైన్ క్లాసెస్ మళ్ళీ మినిమం రిజిస్ట్రేషన్ ఫీజుతో క్లాస్లో కూర్చోవడానికి అలౌ చేయడం జరుగుతుంది. ఓకే, ఈ కోర్స్ అనేది మళ్ళీ చెప్తున్నా, ఈ కోర్స్ అనేది మీకు విదిన్ టైంలో కంప్లీట్ చేయడానికి మనం టైమింగ్స్ అట్లా సెట్ చేయడం జరిగింది. సో విదిన్ టైం మనం సిలబస్ అనేది మొత్తం కంప్లీట్ చేసుకోవాలి, రివిజన్ అయిపోవాలి, మాక్ టెస్ట్ ఎగ్జామ్, గ్రాండ్ టెస్ట్ ఎగ్జామినేషన్ రాయాలి, అండ్ డెఫినెట్లీ జెన్కో జాబ్ అనేది డెఫినెట్లీ వీ హ్యావ్ టు సెక్యూర్ దట్ జాబ్. ఆన్లైన్ విషయానికి వస్తే ఎవరైతే ఇప్పుడు ఆన్లైన్ కోచింగ్ సాయిమేధ కోటి హైదరాబాద్లో జాయిన్ అవుతారో ఇన్ ద యాప్ స్పేస్ గేట్, ఓకే, వాళ్ళు ఇప్పుడైతే ఈ ఆఫ్లైన్ క్లాసెస్ ఏదైతే మీకు వీడియో క్లాసెస్ జరుగుతున్నాయో, లైవ్ క్లాసెస్ జరుగుతున్నాయో, ఆ వీడియోస్ కూడా మీకు యాప్లో అప్డేట్ చేయడం జరుగుతుంది. సో అడ్వాంటేజెస్ ఇన్ ద ఆన్లైన్ కోచింగ్ అండ్ యాజ్ వెల్ యాజ్ ఆఫ్లైన్ కోచింగ్, ఇలాంటి ఆఫర్స్ ఉన్నాయి కాబట్టి ఖచ్చితంగా as soon as possible download the app and join in the Saimedha Koti Hyderabad guys. మీకు ఏ డీటెయిల్ కావాలన్నా ఆఫ్లైన్ కోచింగ్ గురించి, ఆఫర్స్ గురించి, ఆన్లైన్ కోచింగ్ గురించి మన యాప్లో ఉన్న మొబైల్ నెంబర్స్కి, మన స్క్రోలింగ్లో ఉన్న మొబైల్ నెంబర్స్కి, డిస్క్రిప్షన్లో ఉన్న మొబైల్ నెంబర్స్కి కాంటాక్ట్ చేయండి. దిల్ హెల్ప్ యూ ఫర్ షూర్. థ్యాంక్ యూ వెరీ మచ్ గైస్. దిస్ ఇస్ మొహమ్మద్ ఇంజమామ్ విత్ వన్ మోర్ వీడియో. ఐల్ కమ్ బ్యాక్. ఆ వీడియో అనేది నోటిఫికేషన్ మీకు రావాలంటే ఖచ్చితంగా ఈ ఛానల్ని సబ్స్క్రైబ్ చేయండి. థ్యాంక్ యూ వెరీ మచ్. ఐ విష్ యూ ఆల్ ద బెస్ట్.